Yeah.
They're not too late either. So Dan's been with the company since 2014. Prior to that, he worked for Apple, Dun & Bradstreet, and had his own programming shop for about a decade. Worked in many different systems, many different languages. And I told him I was going to make some stuff up, so in his spare time, he likes to knit and do pottery. So that's really cool. Y'all can ask him about that later in his spare time. So he's going to talk about data patterns, profiling, and ECL Watch. And welcome to the audience here. We're also live streaming, so welcome on the live stream. If anybody has any questions, let me know so I can give you the microphone so that they can hear on live stream. That's your only bit of housekeeping, and I'll turn it over to Dan.
All right. Thanks, everybody, for showing up. For those of you who don't know me, which I'm not sure if there's anybody here who don't, I said I'm Dan. I'm a thaumaturge. I have a business card that says that, so I'm going to claim it. I'm actually a senior architect, but I like thaumaturge. And I work for the Solutions Lab. So we're here to talk about data profiling. And actually, I did a presentation last year about data profiling. So this is kind of an update to that. It has changed a little bit, and we've kind of made it a little bit nicer. So this is what we're going to cover. It's not too much, but I'll let you get started. So I think everybody here should know what data patterns is. Is there a show of hands of somebody who doesn't? Nope? Okay. So data patterns is the shorthand for this. We're commonly saying data patterns, and what we're really talking about usually is data profiling, which is profiling as part of data patterns. But data patterns itself is an ECL bundle. Like I said, primarily it is a data profiling tool. I should put my glasses on so I can see something. It's primarily a data profiling tool, but there's a few other things that are involved in the bundle. And by data profiling, what I mean is it's a tool that will examine a data set in HPCC and take a look at every single value in every single row, every single field, and try to figure out, is it optimally represented by its data type? Its mins, maxes, if it's numeric, if what its shortest and longest lengths are, averages, some other numerical constants. A nice thing called data patterns, which is where the name for this comes from, where text is converted into a fixed palette, so you can see where letters and numbers and punctuation show up. The sum of all of this, basically, is it allows you to look at a data set and try to figure out what's in it, in a general sense. That can help you write code that can consume it, clean it, things along those lines. It's not very hard to run. It takes like 3 lines of code to run. And with some of the changes here, it makes it even simpler. And we'll go over that in just a second. Wow. This is actually an example, and I'm not even going to do that. Okay, it is so fuzzy. That's an example of the raw output that you would get, which is an attribute of, which is a field, the given attribute, which could be a string. If you had just sprayed a data set in, and everything is a string then, but by looking at every value inside that data set, it could be a number. And then how big should the number be? Anyway, it does all of that. And then the patterns are over there. No, this one stops with modes. We'll show you the patterns shortly. So from last year, data patterns, by the way, has been around for about 3 years in some sense or another. It was published as an official ECL bundle a couple years ago, or about a year ago, maybe 2. But we made some improvements since last year. So the last time I gave this presentation was a much more in-depth thing of what data patterns is, or profiling, and what it could not do. So there were some things it could not do, and we have corrected that. So one of the things we added on the profile side specifically is cardinality breakdown. So if you can see, I'm not sure if it's in focus or not, but the example data record up there, which is just a year, month, and num sold, some sample data. If you run data patterns against that, and data patterns sees a low cardinality for a field, then it will automatically provide a breakdown of the values. And by low cardinality, that's 64 by default. You can define it. The result is showing up here. You can see cardinality breakdown for year, and you can see 2018, 17, et cetera, and the number of times they show up. So that's something that's automatically provided across all fields if you enable it. UTF handling was improved. Before, if data pattern saw a UTF-8 field, it just said, okay, great, the optimal type is UTF-8, go on. If it was actually comprised of a lot of numbers, you never saw that. Now, it actually looks at the contents and makes the appropriate recommendations. There was a couple bugs with lengths as well that were solved. We support additional data types, and these were big things that people wanted. Embedded child records and child data sets, especially. So the second example over there is a child record, an embedded child record. The way that's now handled is you look at it with ECL syntax, basically. So you can see sold month and num sold were both in the child. Now they appear here. The numbers that appear, you've got a record, the fill rates and those kinds of things are calculated data set wide. So it makes sense on a record. For a child data set, which is that example over there, it's almost the same thing, only it says data set instead of record. You get almost exactly the same output, which can be a little confusing. So if you have one record in your data set and a child data set with 1 million records in it, then your rec count could look like 1 million. Okay? Because it basically expands it out. It's almost like it normalizes it. It doesn't, but that's what it looks like it does. But the support is there. And last thing, we're support for set ofs. So sets were not originally supported at all. Now they are. You can see the cardinality breakdown. You can see a demonstration. So the sets are, what they're really done is they are converted to strings, a string representation, and that value is used to construct cardinalities, fill rates, and those kinds of things. So best record structure is another thing, and this is a lesser known function macro, part of data patterns. The profile provides as one of its results for every field, it tells you what the optimal record type should be, or data type should be. So given a string, but hey, it should really be an unsigned 2, right? Best record structure runs on its own a profile asking only for the best attribute for every field. It doesn't do the full thing. And then given that information, it returns a record, so a record definition. And you can copy and paste it. Now, you can also get the transform that comes with it. So it's a Boolean, you can say, do you want the transform? And in your result, you can get one text blob that you can copy and paste that contains a record structure for the best version of that data, as well as a transform that you can just plug into a project. And it's the best type of transform. So if you've got fields that don't need anything, they don't exist. If they will implicitly convert, then they don't show up. It's only the ones that are trouble. They're the ones that show up. So that's been added. And then there were a lot of myriad bug fixes, of course. Okay, and then the fun part. So I didn't do this bit. Oh no, I did this bit. Forgot. I don't do the next bit. So as of 7.4.0, we got it moved over into the standard library. So it's no longer a bundle. So data patterns, profile, and best record structure, both of those macros are embedded in the standard library, the ECL standard library. So it's very cool. You don't have to do anything. You just import standard, call that stuff. There's an example down at the bottom of how you can do it. And that particular example, you don't even have to know the record layout of the data. Providing it is actually part of the metadata for that file, that'll work. It'll just read the layout at compile time and do its job. This part I didn't do. So Gordon Smith and Jaman Umbridge, can't remember his last name, put this together. There's actually, you can't hardly see it because of the resolution here, but inside that circle is the word data patterns. So as of 7.4.0, inside of ECL Watch, inside the Logical File Details tab, is this tab, or inside that pane is that tab. So that's some sample data I've got. If you click, oh, well, here's a diversion. That's the record structure for that file. Okay, that's exciting. But if you go into that tab, you have the opportunity to execute a data pattern run, data pattern profile run. If you've never run it before, then you'll get presented with pretty much a blank screen, but you can choose which engine to run it on. So if it's a very small data set, an HTHOR run or a ROXY run may be more appropriate. If you have a very large data set or a lot of fields, Thor would be better, but you can choose it there. And once you do, you click the Analyze button, and you'll get a work unit back. Over there on the right-hand side, you can see kind of the breadcrumbs. They'll actually light up and go over as the thing is running. Data patterns profile can be an extensive, long-running thing if you've got a very large data set. Now, when you run it from ECL, you have an awful lot of arguments that you can supply to the function call to trim that down. You can analyze just a fraction of the data, only some of the fields, and those kinds of things. This executes against all of your data. But you get the work unit, so you could go and look at it if you wanted. And that's actually looking at the work unit and looking at the ECL that the JavaScript behind that button wrote for you. And it started that whole thing off. And then eventually it'll finish. And this is not the first thing you see. It's the second thing you see if you click around. But for presentation purposes, I decided to order it this way. That's the raw data. And it looks really bad. That first field took up the whole screen. And here's the second field down here, and then everything scrolls down past that. But the cooler part was this. This is what you see. These are the results, and they're pretty. They're not just a table of numbers. Now, not all of the table of numbers was converted to pretty, but these were the important ones. And it's nice that we have now something that you can click, no programming necessary. You click a button, you get something like this, and you can immediately see some important information about your data. There is here inside of this red box, and again, the resolution is not the best, but the name of the field and the given type is there along with the recommended type, the optimal type. Here you've got the cardinality amount and also the fill rate. And one of the nice things here is the cardinality in the raw numbers is expressed only as a digit, right? Not a percentage. They provide percentages here, so you get both. So that can be a nice little thing. For strings, up there you see minimum, maximum, and average length of the filled strings. For numbers, you can get some quartile information, mean, standard deviation, and quartile. We got some graphs. My presentation doesn't have this, but notice there's a pop-up there. It defaults to a min-max. This graph is actually minimum, maximum of the value inside of that field, and these bars are the quartile numbers. So you can see where they are, and pretty much the graphs almost all look the same, in my examples anyway. But you'll see it's the quartile breakdown. There's also a normal distribution breakdown and another one that I can't remember off the top of my head. We can do a demo if anybody's interested, and we can look at it. There's the cardinality breakdown that we added. It's now showing up here. And then there are popular patterns. So I talked earlier about converting actual data into a small palette of letters and numbers so you can see what your data looks like kind of at a pattern level. The popular patterns are here. Now, those of you familiar with data patterns profiling know that there's also a rare number or rare pattern result, which is extremely useful when you're trying to clean data because then you can look at stuff that is an outlier. This doesn't show that, but it will show you what the most common patterns are. So we have data patterns profile started out as an ECL bundle. And then we put it into this ECL standard library. And now it's available from ECL Watch. So it's 3 different places. And they all work a little bit different, unfortunately. As of today, these are the differences. So the bundle, if you go out and install it as a bundle, or you just clone it and kind of include it in your code base, that's the most complete feature set, okay? That one gets a few additional functions, actually function macros. So that profile from path is the same thing as profile, and with the dynamic record lookup, but it also will tell the difference between CSV and Thor flat files, and does a little bit more magic for you. So in other words, the bottom line on that is you can do a profiling knowing only the file name, okay, at compile time. Best record structure from path is the same thing. It's a best record structure. You give it only the file name, and it'll go and deduce what the record format's supposed to be. It does contain that pretty print, that pretty report that's embedded in there, and that's where you get it from. It's up on GitHub. Okay, inside the ECL standard library, if you do an import standard and call it, you do not get the pretty report. That pretty report that you see from ECL Watch is provided by ECL Watch, not by standard. So if you go this route, you don't have to install anything, but you don't get everything. That may or may not be important, right? The worst thing is you don't get the pretty report. Like I said, it is available from 7.4.0 and later. And then the ECL Watch version, it only does data profiling. It doesn't do anything else. And there's no control over, when you actually run it, there's no control over all its bells and whistles. Are there any questions so far? Yes. Oh. Hold the question. And then don't speak into the speaker.
Hey, Dan. Yeah. Hey, Dan.
Ah.
Yeah. Hey, Dan. Is there a particular filter where you can limit the patterns? Because, I mean, this data pattern is similar to the SALT profiling. SALT has similar kind of profiling, and
yes,
we can see the patterns in there too. And what I have noticed doing profiling in the past is whenever I limit the pattern to maybe 25, because the default in SALT is 300.
Okay.
And if I limit it to probably 25 or anything, and if I run it on probably like 200 or 500 million records, that is when the amount of time decreases drastically. So when I'm looking into the ECL Watch and I go into the data patterns tab, is there a particular filter or anything where I can actually limit it?
Not through ECL Watch. There is, if you use ECL to call the data patterns profile, you can give it the number of pattern records, and that applies to both the popular and the rare. I believe the default, I can't remember if the default's 50 or 100. It's been a while since I've looked at it. But you can dial that up or down. Now, that said, it probably will not affect runtime too much by dialing it either up or down, because they are all computed. So the whole list is computed, and you only see the top and the bottom of that list. And the whole list is used in order to, it's part of what goes into figuring out what the optimal data type is. So, I mean, you can definitely play with it and see. But yeah, you can dial it up and down. If you go through ECL Watch, it's kind of like you get the whole file and a bunch of defaults.
Does it also list out characters? I mean,
yeah,
characters and okay.
Yeah, I think it uses the same patterns as SALT. So numbers turn into 9s, uppercase letters are uppercase A's, lowercase letters are lowercase A's, all other punctuation's the same.
Okay, yeah, thank you.
So you say the ECL bundle provides the pretty report. Does that mean that you also need the visualizer bundle installed?
No, and as a matter of fact, I opened an issue with Gordon because you cannot have them both live at the same time. We found that out. somebody was trying to do something else. So no, it does not rely on Visualizer. I think he borrowed a lot of that code. But there is some, looks like there's some rationalizations we need with some of these bundles that have extra things like manifests. They tend to collide if you don't make the names right. Great. Any other questions? Richard.
Are you planning to reduce these differences in the future?
We're going to look at trying to, yeah. We've had several people, particularly this. I think internally when we were talking about exactly what should go into the standard library, there was a kind of a philosophical thing about should a non-ECL code go into the, or non-code really, go into the ECL library. And I guess they erred in one way, which is only ECL should go. In other words, the pretty report is JavaScript and a bunch of things along those lines. So that's why it wasn't included, but maybe we can get that fixed. Excellent. Any other questions? No. Yep. Behind you. They're doing that on purpose.
We know like a data profile generates some data. Can that data can be read from ECL somewhere?
I'm sorry, I didn't understand.
Like a like when you run the data profile on a data set, it generates an output. Can that output as a programmatically can be read?
Can we save it and use it?
Yes.
Yeah, absolutely. As a matter of fact, so I think you're conspiring against some other, or with some other people, because probably in the last 2 months I've been asked by 5 different people for that exact same thing. And I have a function macro that will take the data patterns profile output and normalize it. So the flat parts. So you would be missing the rare patterns, popular patterns, modes, and correlations. All of those are, and cardinality breakdown. All of those are child data sets. They all come out. So if you have a flat data set, I can normalize that whole thing, which makes it great for saving as a Thor file or even externally, so you can then compare consecutive runs of data, right?
That was the purpose.
Yeah, that's exactly it. Because there are some people that have taken the standard profile output and saved it, but then they have to pick it apart, and that can get a little messy. And you reminded me of something, and what was I going to say? No. Okay, it'll come to me.
So like if ECL bundle is present and ECL... I think it's a small room, so
I know, it's hard. They should just issue everybody a microphone.
I'm sorry.
So you're going out live right now.
Oh, no, go ahead.
So if ECL bundle is present and ECL standard library is present, which one takes precedence? Is it the bundle or the...
It's a standard import order, right? So it's however the imports are resolved. If you did, let's say you installed this as a bundle, okay, and then you said import data patterns, you would get the bundle, okay? Because standard, you need to import standard in order to get the standard version of it. Now, do you know, Richard, if you have, let's say you have a top-level folder called data patterns and you have a bundle called data patterns, which one gets imported? Do you know?
No.
Okay. So that's something we need to find out. Yeah, I don't know. I'm not sure, because that's the only case I know of where it could conceivably come from one of 2 places, and I don't know which one takes precedence. Okay. Well, not going to let everybody go just yet, so there's a little bit. I want to take this opportunity, because I have a captured audience here, to talk about a couple other things. So data patterns, as I said, a lot of people use data patterns as a synonym for data profiling, but we fully intend to put more things into it. Flavio was talking about this during his keynote. In fact, I think he just gave away like in the majority of the rest of my presentation here. But this is something that we're working on. It's called data detectors. Hopefully this will become part of data patterns. So it'll be something like Profile, only we run it differently. What it is an attempt at creating data detection, looking at data sets. Think of columns, regular data sets, but looking at individual values and trying to figure out what those values really are. Given a column of things, of strings, can we determine that the majority of those values are something? And we're not talking about just other strings. We're talking about a person first name, or a person last name, or an email address, or whatever. What we've done is try to, figure out how to do this. And along the way, we built up some models. We have Bloom filter models and heuristic models. The difference between the two is basically set membership versus patterns. So an email address has a pattern, right? Whether or not a string, camper, is that a first name or a last name? The only way you know that is by example. It's a member of a set, and the set of person last name. So we're using Bloom filters for that, which are really cool. And internally, what we do, we have a lot, LexisNexis Risk has a tremendous public records data set. We have information on a lot of people. We have their names. So I went to that. I extracted all their names and brought it in and pumped it into a Bloom filter. And I can use it as a gigantic test membership. And the way that works is if I've got a field, it's a string, I just say, is that a member of that Bloom? And if it is, I mark it yes. You do that for all of the values in that field, and basically you do that with every model. And who wins? Who's got the highest count? And is that count the majority of the items? So if we have 1 million records, there has to be at least 500,000 filled values that belong to person first name before we'll call it a first name. Does that make sense? And the same way with the heuristic models. And we've done all of these. This was pulled from the code. But the goal is to be able to do that kind of thing. So we look at data and say, not just is it a string, but is it a person first name or person last name? Or is it a Germanic name versus a Russian name versus an American name versus something else, right? The possibilities are pretty good. There's a little bit of an example here, some raw data. This is like stock data. It's not people information, which is not that exciting. But this is an actual test run, which you can't really see because it's fuzzy. I'll have to tell you what it is. So over here, this is field name out of that test data. And there are things like closing price, stock symbol, trade date, trade quarter of the year, shares traded, month, a rec ID, and a year. Okay. Over here, when we run that data against our modeling, all of those models on that one screen are actually tested. These were the top 3. What's shown is for each field, the top 3 appear. In order to get a green check, you have to be, get at least 50% of the count, and it has to be true. It has to be filled. And for the green, that came true. So for all of those fields, for those 8 fields, we missed on 2 of them, so 6 of them we correctly identified. If you look at some of the ones we missed, most of the ones aren't too bad. I mean, trade year could have been a stock symbol, I doubt it. But if you look over there, it's really a false because there was very few. You had to have more than 50% to get it true in that last column. Where it gets interesting, and rec ID, by the way, is one of mine. So is the cardinality equal to the number of records? So you got unique record IDs. That's one of my favorites. Trade quarter and shares traded. Shares traded, it's a number. That's going to be really hard. We've got some ideas. Maybe we can use machine learning. Not sure. Trade quarter is really hard. It's a number, 1, 2, 3, or 4. Is it a quarter? Is it a month? Is it a day within a month. You know, you don't know what it is. What we're going to have to do is take like another pass. Once we do this, we take another pass. You can't have a trade quarter without a date. Somewhere in that data set, you'd have to have a full date, or at least a month and a year in order to get a trade quarter, or to get a quarter. So some of these fields can support each other. We also are going to do an analysis of the field names. So if we have something besides field 1, field 2, field 3, we can tip the scales. You know, if you see F name, it's probably first name, right? That's where we're going with that. And, okay, that was 2. I'm not very good at indexing. Depending on what language I'm in, it's either base 1, base 0. This is also something that Flavio talked about, which is the Cloud IDE. And Lily's in the room. I should have her come up and talk about it more than me. But we've started development on getting a basic IDE written that's actually just dropped in a browser. So you open up a browser, you go to a URL, and you've got an IDE for ECL. It's a very basic thing right now, but it's got a lot of promise. You sign in, you get a workspace, you can have code. They are calling them scripts, so it's kind of like small code, smaller data, because there are browser limitations for moving data around. But it's, for someone, this is especially fantastic for someone just coming into ECL, HPCC, trying to figure out what's going on. They don't have to install 5 things just to get Hello World, right? I mean, it's kind of like the playground, but it's a little bit more IDE-like than the playground. You know, it's pretty nice. You've got code, you've got typical file type stuff. Behind here, you've got graphs. You can get, you know, within one browser pane, you can get a whole cornucopia of things. So the visualizations are there, data patterns is there. Really cool stuff like taking a data set from that list on that data set up there. You can take the data set and drag it into your code window and get a layout in ECL. It's got some pretty neat features. And that really is the last thing. So, have any other questions? Any final questions? Any non-related, unrelated, quasi-related? Yes.
So hi, I'm Vanilla. I'm asking the question as a student. So HPCC systems came to my school, Kennesaw State, for an hackathon.
Yeah.
And the competition was about analyzing some data. And for the analysis phase, I guess we mostly run the profile function. So yeah, we run like, yeah, almost all the time. So my question was, is there any work, because we realized that it was taking time. So we know it does a lot of things, but I don't know if there's any work in making it faster, because we realize that whenever we want to run the profile function, we run it and do something else, like, yeah, maybe we can.
Yeah.
And then yeah, basically. Just to know if there's any work in making it faster, maybe.
There's the most common way of making it faster is, this is not through ECL Watch, but if you were actually writing the ECL yourself, you can specify a sample size. And the sample size is a percentage number. It defaults to 100 for your entire data set. But if you think your data is normal, you know, I mean, I shouldn't say normal, like it's evenly populated all the way through it, then tell it a sample size of 10. So you get 10%. Or even 1, you know, for 1% if you have an extremely large data set. It depends on what you're interested in. Like if you're looking for the patterns, then a 1 is fine, right? Unless you're looking for rare patterns, then you need to look at the whole thing. So it kind of depends how you want to go. And I remembered what it was from 5 minutes ago, or 10 minutes ago. I neglected to say in the ECL Watch, when you kick off the profiling, you know, it's a regular work unit ID, right? Well, that work unit ID is saved for that file inside the new WS Store service that is in 7.4.0 as well. I don't know if you guys know about that, but it's a key value store. It's associated with the ESP service. You can use it for whatever you want, and there's also a standard library module for it as well. But the point is, the work unit's there. And the Java or the JavaScript code saves the work unit for that file there. In other words, it's cached. It's still there. So you kick off the profiling, you go away, come back to it, and you see it, it's pretty. You close it, it's not gone. If you went right back into it and opened up data patterns, the results pop right back up. So the code will go read the work unit, go try to get the work unit results. If they're there, just read them. Now, eventually, the work unit will be archived. And then you'll have to run it again unless you protect it. But it is put away. Anyway, that's what I was going to add. So did I derail any other conversation? Any other questions? No?
All right, well, thank you so much to Dan Camper for giving us this presentation. Thanks to the audience here and on live stream. Dan, one last question is, in data detection, so would champion be a surname or a title?
Yes.
Thanks, y'all.
Thanks, everybody. Awesome.